Hey everybody, Mr. Regan here. And today we're going to be looking at a key concept that we are going to be focusing on to help us not only understand this relationship between force, mass, and velocity, but also to help us apply this idea to any other situation we encounter or any other question that might come up as we look to understand how these three concepts, force, mass, and velocity, interact with one another. So, in a relationship, when it comes to force, mass, and velocity, we like to look at this idea that if the same strength force is exerted on two objects, but the objects have different masses, the objects with less mass will have a greater change in velocity. So, what that tells us is about these three things and how they act with one another. How, if we have one, we can usually infer how that's going to affect the other three. So, for example, if we have three mass objects, a truck, a bowling ball, and a toy car, each one obviously has a different mass, the truck having more mass down to the toy car that has the smallest mass. If we were to apply the same strength force to all three, we would see that the velocity change for the truck would be a lot smaller compared to the bowling ball, and the bowling ball would be a lot smaller compared to the toy car, and vice versa going all the way up. The toy car would have a larger change in velocity when we apply that same force versus the other two. But what makes this relationship unique is if we were to change these in any way, we would also see a change in the other two. So, for example, if we were to change the force and we were to increase the amount of force, so let's say we go from 35 here to maybe 55. So notice we're applying the same force still to all three, but now it's just more. What we would see is a change in velocity. The velocity change would increase because we increase the amount of force, but we would still have less of a velocity change with the truck, less of a velocity change with the bowling ball than with the toy car. So we would see a bigger velocity change with this smaller mass object than with the other two. So just because we change the force doesn't necessarily mean we change the effect on the velocity. Yes, the velocity change would get bigger for all three, but we would still see that proportional change. Notice if we were to make this smaller, say we rewind it, and now it's let's say 15. So notice we're applying a smaller amount of force to all three objects, but it's still the same. We would see that all three of their velocities would change. Smaller force, smaller change in velocity. But again, that small amount of force still has the same proportion to how the velocity would change. Yes, the velocity change is smaller for all three, but we see the smallest with the high mass object, a medium with the medium mass object, and a big velocity change still compared to the other two with the smallest mass object, that toy car. So notice this relationship. As we change one thing, yes, the other will change as well. But if that mass is different, we're going to see that no matter what, if the same strength force is exerted on two or more objects and they have different masses, the object with less mass will have a greater change. The object with more mass will have a smaller change. So that's our key concept that breaks down how our vocab helps explain this relationship between these three things. If you have questions, reach out. Otherwise, good luck.